Okay, we'd like to start looking at some redistribution scenarios and examples. Here what we have on the right is a very typical example. The diagram's been a bit extended, but basically we have two autonomous system border routers here. Okay, they're running RIP and OSPF. And at the top we have a sort of a RIP domain. At the bottom we have an OSPF domain. And this could be a backbone, it could be MPLS. The RIP may be a single router, it could be a data center just bouncing routes backwards and forwards, or it could be a larger group. Age-old problem. We want to move the OSPF routes into the RIP. We want to move the RIP routes into the OSPF, mutual redistribution. Of course, we have two routers that are running both protocols. That's 2 points of redistribution or two ASBRs. And that's pretty standard, so that if one breaks, you don't sort of lobotomize your network. Okay, so let's go through the details. What we have here is we have routes that are being grabbed and selected by a policy statement. They are being taken out of the RIP protocol, and this would be considered a RIP export. Here we see routes that are selected inside the table by a policy statement that's selecting the RIP routes, and they are being taken out of the router as an OSPF export. So if the route is, whichever route is selected, if it's coming out of RIP, it's considered a RIP export. And if it comes out of OSPF, it's considered an OSPF export. It's worth noting that Cisco, Juniper's main competitor, do this exactly opposite. If it was coming out of OSPF into RIP, it would be an OSPF export. If it was coming out of RIP into OSPF, it would be a RIP export. However, doing everything routing table centric really adds to the clarity of this entire process. And so regardless of the source of the route, whether it's an aggregate, whether it's a direct route, RIP, ISIS, OSPF, if it comes out of RIP, it's a RIP export. It comes out of OSPF, it's an OSPF export. So the routes, the RIP export goes into the RIP domain, and as they arrive at the second ASBR, we want to stop them from going into the table. And the reason we want to stop them from going into the table is if they manage to be selected to go into the table, then obviously, as they're in the table, they may well be selected to become OSPF exports. And then that would come back to ASBR1, and ASBR1 would be looking at its own route via ASBR2, which is not a good thing to do. So we're going to block it on the way in. We consider this an import. So if it's going from the RIP protocol daemon into the INET 0, it's a RIP import. If it comes out into the RIP cloud, it's a RIP export. So why are we doing this? Why are we taking routes out of the INET 0 into RIP only to prevent them from coming back into the second ASBR in a meaningful way? And of course the answer is the RIP up the top here. There are other routers here that will benefit from these routes that are coming from the first router into the RIP. And that could be a large cloud, could be a single router, but it will benefit from them. Okay, so how are we going to do it? Let's have a look at the commands. We've got the policy statement, we've called it OSPF to RIP, and we've got terms. We're grabbing the OSPF routes, we're tagging them, and we're accepting it. And then we're actually attaching this export onto the RIP protocol as the routes go into RIP. And in RIP, very similar to BGP, we need groups. On the other end, on ASBR2 or ASBRB, we are building a policy statement which will filter the RIP, and we're going to be looking for that tag, and we're going to be rejecting it. So of course, RIP is going to be rejecting itself because this becomes an import filter on RIP. And of course, the source will always be the same protocol on an import filter because it's coming from its own database or storage, not a database in RIP's case, into the routing table. And there we have the top. On the bottom, the OSPF has a parallel position, and we'll look at that in the next video.